So if you see these two listings exactly similar the information. Okay. So the variables you can see subject number and the test, visit, normal range high to low, date, time of measurement, results and flag. And in this listing also you will see the same information subject, test, visit, normal range, date, time, results and flag. But the 16 to wide they want to expect a abnormal hematology related values, and 16 to 17 they want to keep the biochemistry related values. Okay, so PARCAT one chemistry related results they want to keep in this listing. So in this hematology related value, so the outputs both are same, but the only the condition is different. In that scenario, how your senior programmer tell, instead of creating the two program, create one programming to generate these two outputs at a time. Okay, so that time how to write a program. Okay, first we'll focus on this one. After that one, I'll show you how to macrotize the programming to handle the two outputs at a time. Okay, so first as usual, header part as well as the libraries, how we take in the listings. So similar way, you just take the header part and libraries. And this program name I have given 16 to 17 and white loop. Both we are going to handle it. So I'm just giving 16 to 17 and 8. Let's save this program into our program folder. Okay, so this is 31st March. Yeah, first of all, what are the variables are there in the data set? We keep those to start. So here they mentioned everything comes from the ADLB data set. Okay. So the first listing, the main condition is they want to include only the chemistry related records for this listing. So parcat one equal to lab data set, in that to the parcat one, here you can see in this only the chemistry related records. So many their hematology, chemistry, so many there in that. So they want to filter parcat one equal to chemistry related records. Okay, and this is the condition. So first change here. Okay, so next we just keep the variables. What are the variables we want to keep? First one use of JID. Next one is so parameter. So if you see here parameter related information there here. But if you see parameter short form, parameter numbering. Okay, here you can see the label of this one is parameter n nothing but they given certain numbering. So albumin they given 21, alkaline phosphatase they given 30. So why the number given? Because whenever you are creating any listing table figure, so whenever you are using this parameter information, you can use this sorting order. Okay. So whenever you are using any variable, that time you just concentrated any numeric version variable is available in that particular variable. So use that variable for the sorting purpose. Okay. So this is for sorting purpose. This is for display purpose. Okay. They want to display only the parameter. So if you directly use what happen, it is going alphabetical order wise. But we have a numbering there for the parameter. So we use that numbering variable for the sorting purpose. Okay. So next visit. So they want to keep a visit information. So if you see here a visit, yeah. So there is also a numbering variable. So we can use the a visit n and a visit. Okay. And the next variable is so low and high values. So low value and high value. And next LBDTC or ADT. So which variable is available, we can use that variable. So LBDTC not available, ADT variable is available, and ADTM also available. So here you can see ADTM, some observations having timing variable. So some observations we don't have that variable. Okay, we can use the ADT variable only. And next, finally, AVALC and ANR&D. Just keep. Okay, so chemistry related, this variable they want to display in the listing. Okay, ADLB data set. So this variable is character. This variable is numeric version variable, character, numeric character. So what we do, so if these two are in a character form, but they want to keep here, you can see low and high value, they want to concatenate it together and display under the one variable. So what we do, so low and high values, we just concatenated with the text function, low value, comma, high value. Okay. So this variable we are going to display in this place. And this ADT also in a numeric version variable, we are going to display in a character version. So for that purpose, ADT underscore ADTC. So we just convert them into the character. So ADT 89 format. Okay. So ADTC. So we are not changing any value. We simply change the format of that value. So now all the variables are character variable. So this we are not displaying. This we are displaying. So this is a numeric, no issue. And here this is a character, and these are character. So high value. Why high? Yeah, yeah, low and high, and this is a ADT. See. So now we sort the data set. So as it is. By this order you can sort, because that order only we are going to display, right? So you can sort this order by. So first subject, so parameter 14, next 15, 17, 18, 19, like that. So within the 14 parameter, so these are the visits are there. First screening and schedule, like that. Okay. So now we will write the proc report section to display all this information. Just copy this section, paste it here, and the title 3 only we have to change. So this one. Okay. So for example, if you are creating the 16:17, this title 16:18, so the abnormal hematology related title. So here, so two listings we have. This is a second change. So the first change is here. So if you are creating the chemistry related record, you need to filter the parcat1 chemistry. If you are creating the hematology related, so you need to mention the hematology. So second change the title, and the third change is here the footnote what they mentioned. Yeah, so actually footnote should be no, so program name only. So listing 7. This should be so which program you are creating, that program. So listing 16 to 1, 7 and 8. This is a program name actually. So here they mentioned something other. So both we are creating the same program, right? Because we are using one programming to generate these two. Generally footnotes mention, which program. Whenever you open the output, just see which program you are using to generate these two outputs. And the output also 16 to 1, 7. Okay, this is a third change. Yeah. So the first output and second output, the three changes we need to make. So title we need to change and output also. Second output 7, 8. First output 7. Okay. Now write the proc report section. So what is the dataset ADLB and what are the variables we need to be display under that one? You have to keep in the column statement. Column also will act as a by variable. How the proc sort by variable acting, this also acting as like that, automatically sorted. So now define each and every variable. So the first variable use of JID, just copy this syntax and paste it here. Use of JID. So here subject number, we want to display first line, number second line. So subject and number. So I am giving the 15 cell width out of 100, out of 99 I am giving. So next variable is parameter. So parameter also the label is test. So if you are directly giving what happened this one, so it will take alphabetical order wise of the parameter. So for that purpose, we have to define the parameter numeric version in the order, but we are not printing. The numbering they are not asking, only the test they are asking, right? So this information will sort the parameters in a numbers in a order wise, the order mentioned in the parameter number. So parameter is display wise. Okay, this is displaying, this is not display. So next a visit in and a visit. A visit in and this is a visit. So the visit. So I'm giving around 15 length. So 25, 15, 30, 40, 55. So next low and high. So the label is normal range. Just give the 10. Next variable is ADTC. So data and time off in the first line. Go to the next split character and you can print the measurement. Okay. This 10 next result. That one I will see. That is the result. Date time of measurement. Time of sorry measurement. Okay. So last one is ANRND. That is flag. right? This is a flag only and 5%. Okay. And so above one line and below one line purpose, we created this and close the output. Yeah. So we'll see once how the output is going to generate. Yeah. So abnormal biochemistry related values. So the title showing something abnormal, but here, so the normal values also display. So what we do, we have to add one more condition here, and so ANRND not in normal. So as per the condition, so abnormal biochemistry values only we are going to display. So not the normal values they don't want to display in the listing. They want to check what are the abnormal values are there in the biochemistry. Okay. Now you can see only high low related abnormal values each subject. So the biochemistry related parameters you will find in the abnormal related values. But if you see here only the last page you will see the bottom line each and every page. So you will miss the bottom line here because what it consider everything continuously printing. So the bottom line is missing. To get the bottom line for each page, okay, each page will do. So before that one, we have to do one more thing here because if you see here, there is no gap between the subject to subject and the parameter to parameter. So I am giving compute before each parameter, just I am giving one line space so that we'll see something clear about parameter to parameter. Now you can see there is a gap between the parameter to parameter, so we can easily identify this related to the what parameter. Now how to get the bottom line for each page, because around 9 pages or 14 pages information there, and how to get the bottom line each page. So to get the bottom line each page, if the data is above one page, so we have to handle in the data set level itself. So this will very much helpful for you. So data ADLB2 set ADLB. Okay. So first retain. So line related and page related variable just created as 0. So ADLB2 now you can see. So first what we do, I just given line number and page number. So everything 0. Okay, everything 0. Next, so I'll start with the line number iteration plus 1. So what happen? It will start incrementing one by one like this 1, 2, 3, 4, 5, 5 up to the 331 lines are there, right? So 331 times iteration was happening. So whenever it was started iterating, so I just apply one command. Whenever the line number reaches to the 15th line, so then I will tell to the program. So whenever it reaches to this 15th line, okay, whenever it reaches to the 15th line, so I telling that, so the page variable should increment plus 1, and again you have to start with the line number 1. So this condition will apply and the loop will iterating so again and again. So that what happen? So once it reaches to the 15th line, so this 0 value go to the 1 and again it will start with the 1. Then again 15 lines. Then this 1 was going to the 2 and the line number again will start with the 1. So once it reaches to the 15, the 2 was going 3 and again it will start with the 1. So like that I am holding like 15 lines into one separate group. Okay. So now this page 1 variable I am going to hand add into the column statement and define the page 1 order. So we are not printing and so breaking that the page 1 by page variable. Okay. So that 15 lines it will go and print into the single page. So 15 lines printed and bottom line is present and next 15 lines printed. So bottom line is present like that around 20 to 23 pages were printed. Okay. So this is a perfect output. So whenever you are generating the output, bottom line should be present. And in that you can see the 001 will continue here and the parameters are so as per this one. In the glucose also you can see the as per the visits order. Okay, dates also you can see 14, 20 and 24 like that. So this is for only the biochemistry. So how to macrotize the programming to generate the hematology report as well. So what I do, so three changes needed. First change, second change, and this is the third change. Okay, three times you need to change. So that three places, I just apply the macro ADLB V1 equal to and V2 equal to and V3 equal to. Okay. So this is the first macro variable. So whenever you are apply the macro variable, it should be double quotation mark. Okay. So first chain and here this is the second one and this is the third one. Okay. So now here you just close the macro and now you call that macro. This is a macro name. Just calling the macro. So percentage V1, V2, V3 and the close. Okay. So if you want to generate this listing now, so what is the V1? What is the condition? Chemistry. Okay. So chemistry, you need to pass here the first variable, right? So whenever we ampersand V1 was reserved as chemistry, the chemistry was reserved here and biochemistry related output was created. And second, this should be title, right? Ampersand V2 plus what? Here. So it should be title. So you can directly give the title, but it containing some special character dot. So to handle this one, so percentage str. Okay, this function will help you to mask the special characters present in the string. Otherwise, it won't reserved as a macro variable and it will create a error message. Okay, and third one, ampersand v3. So here the output should be, so this one, the output should be 7. Okay. So here also underscore special character is there. That is why we use the percentage str to mask this one. So now if you run this code, V1, V2, V3, anything we missed out? Open close bracket, open close chemistry. Okay, there is a extension here, so you need to add one more dot. Yeah, so whenever extension is there, that time we have to add that one more dot. So now the abnormal values of the chemistry was printed. So if you want to print this output, simply you can call here. Okay, so this macro, just paste it here, and here instead of chemistry, Adam ADLV. So hematology related. So second one is hematology related, right? So hematology you need to be print here, and 16 to 18. The title should be this one, and output should be 16 to 18. So if you are running this program, first it will generate the chemistry, next it will generate the hematology. So you can see the 16 to 17 and 18. So 18 hematology related hemoglobin, hemocrit, and etc. And here 16 to 17 biochemistry, urine nitrogen and glucose related parameter. Biochemistry have different parameters, and this has a different parameters. Okay. So this is the way. For example, 5 outputs are there with the same layout, only the condition is changed. You can create the macro and you can simply calling the 5 programs step by step. If you run the single programming, automatically all the outputs are generated. Whenever you update anything in the programming level, so that will apply to all the calling programs. Okay, like that we have to create this multiple outputs in a dynamic way to handle the by using a single program. Okay, so anybody having any doubt on this programming, just ask me, I'll clarify you. Yeah, so it is looking like
Hi. Can you
yeah,
please explain again that retain part and LNT part,
yeah,
page one,
here.
please?
So if you are not giving the page control in the data set level, what happen? It will considering entire thing has to be printed in the page. So the continuously printing in the page, so that bottom line is going to miss. So that is why I just hold some 15 lines. If the 15 lines also not fitted, we can reduce the number. If it is fitted, we can increase the number as your wish. Okay. So we have to utilize the complete space of the RTF. So here I am using 15. You can increase 16, 17 also. If still if fitting and producing the bottom line, you can keep that number. So here what I do, so first I create 2 variables and iteration started. Once the iteration was reached to the 15th line, so as in the statement like, so the page number should be increase 1 and the line number will start again from the 1, so that this
Oh,
loop will continues until and unless the all the observations completed. So line number again 1, and when it reaches to the 15, page number increasing 1, again line number will start. This loop will continue like this. So that 15 lines we set a one group called page 1. That variable has to break after page variable. Okay.
so are we using that LNT variable in that proc report or
No,
we don't?
no, 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 no need. Only page variable is sufficient. Okay.
Okay.
Yeah.
Sir,
Yeah. Tell me.
just checking here, instead of retain statement, we can also use nested loop.
You can try. No issues. Okay. So programming, whatever you want, you can try. Okay, just
But
use this program as template and you can write your own code. Finally, you need to produce the two output by using single program. Even I'm not suggested to use my code. You can write your own code also, no issue. Just after this class, try with what the thought you have. Okay, so if it is working, fine.
okay.
Yeah. So nobody is telling use this procedure and this syntax in anywhere. So just they will provide you the mark shell data set and they are expecting the output. Okay, so this is the easiest way to handle the page number. If any other alternative you can find in some resources, you can also use, no issues.
Yeah, but these both steps are similar, similar way, right, sir?
Yeah, yes.
This is a little bit easier.
Okay, then you can use
Yeah,
this one.
this is, yeah.
Yeah, yeah. So now the part is, yeah. So 10 questions we discussed, right? Next 11th question. So if you are not understanding the interview questions also, no issue. Whenever the topic will come, that time you can, recollect the information. So, but if you are discussing five questions in each class, that will very much helpful for you. So once the course was completed, so at a time, no need to by heart all the interview questions. Okay. So 11th question is criterion flags present in the ADAM dataset. Okay. So for example, in one of the ADVS dataset, ADAM related vital signs dataset. So the tables are like this. One of the table is, so they want to keep systolic blood pressure greater than 160 and change from the baseline and systolic greater than 10. Like this, some criteria they mentioned in the title. So in the programmer, what they do, so they will apply the condition. Instead of that one, in the ADAM level itself, they created the flag called criteria flag one. So how many criteria? So for example, five criteria related tables are there. So crit one, crit two, crit three, crit four, crit five. Like that, we have to create the flags in the Adam data set level itself. So that what happen, the programmer no need to derive anything in the table level. Directly he will filter the condition and he can pick the records which are applicable to the table and he will create that output. Okay, here you can see greater than 15 something 160 above related records. We created the flag and the crit one equal to y related tables. They will simply filter this flag equal to y in the table level programming and pick this record and display in the table level. Okay, so even you can see some criteria flag yes or criteria flag no. So if the condition met y, if the condition was not met n. So this criterion flag, so criteria flag 1, criteria flag 2, like that we created so many criterias based upon the tables present in that project. So project have there is no criteria related table. Simply we cannot created or added these variables into Adam level. So if some criteria related, so this criteria meet this table, you have to create. So based upon the condition, we have to create the criteria. So in interviews, so what is the use of criteria flag? And can you please tell me one criteria flag which you created? So that I will tell. So if the tables were generated based upon some criteria or some set of condition, the data set level itself, we have to create the criteria and related flag. So while doing the tables production or QC, we have to filter that criteria flag and you can pick the data and use the data set for the analysis purpose. That is the purpose of main criteria flags. So next thing is sometimes they will ask you what is the variable name base type used in the Adam data set. Okay. So you have to know the baseline definition. Baseline definition nothing but last measurement made prior to the first dose. Generally, for example, if today's subject is taking our oncology drug, so which one having the previous record present in the but before day or previous day, which value there, that value we can take as a base value. So last measurement made prior to the administration of our first dose. So which one happening before. So change how to calculate the change? The value minus baseline value. Okay. So here you will see. So one parameter is there ALT. So that was 1st August, 17th August and 17th August 9. first, second, 9, 10, that was collected. ALT parameter for the one subject. So 9 o'clock it was collected, 9, 10 also it was collected. Okay. So treatment was taken for this subject on the 28th August. Okay. But we have two records are there here. Okay. In this two record, which one is the latest one? So 9 o'clock, 9:10. So 9:10 is the closest value of 28th August. Even 17th August there, but time part you can check. 9:10 is the latest value. So this value you can give the flag ABLFL analysis baseline flag equal to Y to this record. So the value you can see the 410, right? 4.10. This value we can consider as a base value. This is a general definition. Last value prior to the treatment. So three values are there. In this three value, which one is the closest value to the treatment start date? That eval value you can consider as a base value. So here 4.10 value is a base value. So baseline you can assign that value. Change nothing but eval minus base 3.47 minus 4.0. What is the change? But this is a general baseline value. But what is when the base type variable was populated? For example, more than one baseline, we have to populate cases, base type you have to use. So for example, here you can see, so the statistician, if you are directly, we are creating this one. So the base type is last, last nothing but last observation, which we taken as a base value. But sometimes what happen, so if the two values are there, statistician suggests to take the average value instead of the last value. Instead of this 4.10, so they want to take 3.01 and 4.10 average value they want to consider as a base value. So that time the derivation method is average. So base type is you have to mention it as a average. Okay. So otherwise, always the base type is we can take as a last value. But in case the derivation, the statistician suggests to derive in a different way of base value. So which derivation method they want to follow us, that derivation method you have to mention as a base type equal to average. Okay. And here one of the example. So sometimes what happen, so baseline flag is per study, two times it was derived because it is a crossover study. So first time the subject is taking a different time, a different treatment. Second time the subject is taking different treatment. So that time two baseline flags we need to derive each period. Okay. So most of the times, 90% of the studies, we will take a last value of the baseline. Some studies we will take a average baseline if the more than values are present um, in the baseline cases. So that time base type is average, otherwise base type is last. Okay. And next question, sparse versus preload FMT. Okay. So when you will use this sparse, when will you use the preload FMT, which one is effective in the programmatical? So for example, one of the table is there like this, male, female, undifferentiated. So drug 1, drug 2 and placebo there. So they want to calculate how many subjects are comes under male, first drug taken, how many subjects are female, second drug taken. Like that they want to be displayed in this table. So here the data we have only male and female. We don't have any undifferentiated related data in the given data. So that time directly if you are using, so you will get the counts by using the proc frequency. Male is 3 subject, female is 2 subjects and 1 subject. If you directly use the sparse function, what happen? So sparse function if you use here, so you will get the male and male is 0, female is 1, 3 because already the male have one observation there. So the first drug and second drug it will apply. Okay. But we don't get the undifferentiate related type of observations in the sex variable because we don't have any data undifferentiate. So sparse is used. So whenever you have some at least one type of observation there. So then here we can see placebo male is there. Active drug also male. We will get the 0 in case of if you use the sparse function. But preload FMT, what happened? First, we need to define how many types of observations you need. So placebo, drug 1, drug 2 you need, and sex also we have male, female, and a fringe. So you need to create a format. You just apply this format here, preload FMT, and you have to apply the sex variable sex format, treatment variable treatment, and you have to apply the print miss. Even the missing also you have to write. So that time you will get all combinations drug wise male female undifferentiate. If the counts are 0, automatically you will get the count 0. This is the main use of preload FMT and print miss. And sparse option you can use if at least one type of observations are there, then you will get that type of combinations with the 0 value. So most of the time we prefer the preload FMT print miss because you will get all the combination. If the count is there, you will get the count. Otherwise, you will get the count as 0. Okay. Even in future, you will get the data automatically. The 0 will replace with the numbers. And so one more important concept is how to find the last date of the month. So for example here, so adverse event date, you will see 2007 and first month. So they are not collected any, while collecting the date is missing. Only the year and month was populated. So the statisticians tell that, so assign the last date of the particular month. So January last date, December last date, February last date they want to assign. Okay, that is fine. But some months we have 31, some months we have 30. Even the problem is if it is February, whether 2016 is a leap year or not. So if it is a leap year 29, if not other than leap year 28, 28th date we have to apply. So in that scenario, how to write a simple SAS code to find out the last date of the month. So here you can see by using, so first what we do, so the partial date is AE and DTC. So we have to create, so AE and DTC 2, okay, and we just added the, so month E. So INTNX function we can use in that month end, E nothing but end, you will find the last date of the month. So this is simple INTNS function. The month E nothing but, so 0 nothing but there is no increment. So it's directly which month is there, E nothing but the end. So whether it is a leap year or some normal year of the February, you will find. So this is a partial date. This is a actually last date. Okay. So one more method also there. Here what we do. So AENDTC. So first we have to assign the 01. Okay. Next, we will incrementing the month. Jan will be incrementing the February, December will incrementing the January, February will incrementing the third. So next, minus 1 day of this one, it will give the last date of this month. Okay. So this is next type. This is the first type directly UE. Second type of programming is first we need to add the first date. Next, incrementing the month. Then minus 1 day, it will give you the last date of the previous month. Okay. So this is also one type of syntax you will write to get the last date of the month. So last one is for today's class is how to merge the supplementary domains with the main domain in the ADA. So in the SDTM data set, so as per the CDISC rules, so they are stored some variables in the main data set. If some variables are not fitted into the main domain as per the CDISC rule, they created some supplementary data set, means extra data set they created. They will start with the sup, okay, the domain name. So in that cases, while coming to the Adam, so we have to create only one Adam data set. That time what we do, so we have to remerge with the supplementary data set and main data set together. So what is that process? How to do that one in a general way? So first supplementary data set you need to take, and in that, so you need to create one variable, the particular domain sequence variable you need to create. So like this, after that one transpose the data set Okay, so the syntax is similar across all the supplementary data set to the main data set. So ID is QNAM, where is QVal. Okay, so once transpose the data set, you need to merge with the main data set with the supplementary data set, subject and that sequence number. So automatically proper merge was happen. So the interview people ask you the process of supplementary to the main domain merging. You need to take the information and create the sequence number, transpose the data set, and transpose the data set you need to merge with the main data set. While transposing, ID should be QNAM, where should be QVAR. Okay, so these are the common because supplementary any data set you can take only this variables only you can see even it is any type of data. Okay, so QNAM, QLabel, QVAL is there. The QNAM variable should be ID and where should be QVAL, so that proper transpose will happen. The transposed data set merge with the main data set. This is the process of any supplementary domain merge with this main domain. Okay, yeah. So this is for today's class.